Hello everyone, I'm Tifuni here again and welcome to the very first lecture in our HackRF Mastery course. And in today's session, we will deep dive into the ADSP, which stands for Automatic Dependent Surveillance Broadcast. This is one of the best places to begin because ADSP is practical, it's everywhere, and it gives us immediate real-world results. And today we are going to cover what ADSP is, how it works, a little bit of its history, and how to use HackRF's receive functions with ADSP. Also, you will learn about the gain stages here in HackRF, LNA, VGA, AMP, what these actually mean. And we will also decode the message fields like ISAO, call, FL, SPD, alt, and heading. And finally, we will look closely at the antenna choice, which is often overlooked but absolutely critical for good reception. So, what is ADSP? ADSP is a system used worldwide in aviation. The abbreviation itself tells you almost everything on how it works. A here means automatic. The aircraft transmits the data automatically without the pilot intervention. Dependent. It depends on the data from GPS or other onboard navigation systems. S. Surveillance. It provides surveillance data, meaning it tells air traffic control and nearby aircrafts exactly where the plane is. And the broadcast. It broadcasts this data continuously so that anyone with the right receiver, including our mighty HackRF here, can see and can listen. ADSP broadcasts use the frequency of 1090 MHz in the L-band portion of the spectrum. This is a sweet spot because it allows signals to travel long distances with a relatively low power while still providing enough bandwidth for detailed data. A brief history of ADSP. ADSP was developed as a part of modernization of air traffic control known as the Next Gen program in the United States and similar projects around the world. Traditional radar systems could only tell controllers the approximate position of aircraft, often with delays of several seconds. ADSP provides precise, GPS-based positions updated every second or faster. The International Civil Aviation Organization mandated ADSP adoption, and by 2020, most commercial aircraft flying in controlled airspace had to be equipped with ADSP out transmitters. And today, if you are near an airport or flight corridor, you can pick up dozens or even hundreds of ADSP transmissions with a simple antenna and software-defined radio like HackRF or RTLSDR. From HackRF's receive menu, one of the most practical options is ADSP. Now that's why we will begin here. Now it is easy to set up. Signals are plentiful and decoding them gives us real-time aircraft positions and flight details. By using the receive mode, HackRF simply listens at 1090 megahertz and outputs the raw IQ data for decoding software. Here we are. Right now, I'm not in a zone that we have lots of aircrafts and airplanes. but as of the video, we might see some, but it is not guaranteed, of course. Now, first, let's understand the LNA and which is the low noise amplifier, VGA and AMP. The LNA you are seeing here is the low noise amplifier. Now, this is the amplifier closest to the antenna. Now, its job is to amplify weak signals while introducing as little extra noise as possible. And for ADSB, a good starting value is 24 decibels. Now, too much gain here can cause distortion if you are near strong transmitters like cell towers. But in my case, I am not, so I can increase it to the maximum, and the maximum is 40. On the right, we have a VGA. This is variable gain amplifier. This amplifier works at the intermediate frequency stage further down the signal chain. Now, think of it as a fine-tuning knob for your signal strength. A value of 24 decibels is a balanced choice, but you should experiment by slowly increasing VGA until you maximize your message count without introducing too many errors. In this case, I have not I don't have any aircraft in my area, so we are not seeing anything here. By the way, we are using this antenna that comes with the HackRF bundle from the AliExpress. It is from 700 all the way to 2700 megahertz. So this works fine for this particular job, but there are better options. So if you have better options, just use it. Remember, this ADSP uses the frequency around 1090 megahertz. And we also have the AMP on the right of the VGA here. Let's actually decrease it to 48 and right. Yeah, we have the AMP. Now this is a radio frequency amplifier switch. This is an optional amplifier inside the HackRF. And now this can be turned on or off. But you can see it by default it is off. Only enable it if you are in a rural area with a very weak signals. In urban environments, it often causes overload and reduces performance. For most ADSP reception, leave this AMP off. And now we have captured a new flight like 4 minutes ago. It was took 4 minutes to me to set up this camera and recording devices again. And what you are seeing here is we are seeing ECAO number, call sign, last seen, airline, country, altitude and latitude, longitude, speed, and some other airline related information here, even position and odd position frame. I will explain this one by one. So ICAO, this is a unique 24-bit hexadecimal identifier assigned to each aircraft. This is like a digital fingerprint for planes. Now, if you wanted to search this on the ICAO searcher, ICAO 24-bit lookup here, and you can see in the Wikipedia there is information on how you can decode this on your information. You can see in the top is ADSP, mode A, mode C, and other information about the flight. And we have also the call sign you can see here on the right of the ADSP. Let's actually fix the HackRF position a little bit. And what are you seeing is FDB2WK. This is a call sign or a flight number such as this. Now for the American Airlines, you can see ALL. So the first three characters shows the company name. In this case, it is probably the flight Dubai. Let me look from here. Yes, this was going. Oops, please don't fall. So this was going to the from the Tbilisi, the city that I have captured this signal. Let me check the camera. Yes. So this flight was got out from deported from the Tbilisi and will arrive at the Dubai. It is still going, I'm guessing. Let's check from the flightradar24.com. This is a free. Yes, it is probably still going. We do not need such information on our HackRF course. By the way, I have captured this signal live, of course. Yes, it was deported at 12. Yeah, it will arrive at after 10 minutes that I have captured this video. So it will arrive in 10 minutes. The duration of flight was 3 hours and 19 minutes, and the flight is still ongoing. Yes, another thing I will explain to you is the last scene. Of course, this basically is for me that I have captured this signal 4 minutes ago. Airline is Flight Dubai. You can see from the call sign as well, FDB Flight Dubai. The country, United Arab Emirates. Altitude is of course altitude. This is depending on the software. Now this may show directly in a feed as a separate field from the FT. In this case, it's showing normally, and we also have the HDG. This basically means heading. This is a compass direction the plane is flying. This is given in degrees. So basically, the nose of this flight is going at 328 degrees, going at that rotation. The speed 306 kilometers per hour. It's probably in the something, not kilometers, but probably like this is the speed, and that's basically it. And the SQW is I don't know. I'm not more proficient in the airlines. Sorry, but yes, you can look it up on the internet, and yes. Also, the values here lets us build a live picture of the airspace around us. Now, when plotted on a map, we can see the aircraft. You can see there will be a map here. Altitude, longitude. And yes, that's basically how it works on the showing map. You can also change the latitude and longitude, like give your custom coordinations. Of course, when you change the latitude and longitude, the marker on the map will change too. And you can also click on the AC details. You can see a lot of information with this on the about the aircraft, ISO number, registration,
Manufacturer is Boeing. Model is 737NG 8 KNW. The type is land plane. The number of engines is 2, so it probably has one on the left and one on the right. Engine type is a jet engine, which is a common for the tour aircrafts, I guess. And the owner is flight Dubai operator. I'm wondering if you can go back. No. Yeah. That's it. This also gives you a lot of information about. That's interesting thing, yeah, right? You can get a lot of information about this here. So let's go back and see what are we seeing here. Yes, another flight here. Another flight here. How lucky we are, aren't we? Yes, this was also, again, it is gone already. Airline country, AC details. Yeah, we cannot get the information here because the signal is lost. Yes, you can see. This was the old signals that captured. Yeah, you can wait like the half an hour or 1 hour. You will like you have a big chance of getting the airplanes if you are in a at least airspace, right? And another crucial thing I want to talk about is antenna choice when practicing this kind of ADSP receiving. You can see the antenna I'm using is came with the HackRF bundle that I bought from the AliExpress. It works as from 700 megahertz all the way to 2700 megahertz whip antenna, which I guess, oh yes, here we are, another flight. You can see Varesh Airlines, AC details, the type is land plane, jet engine, engine numbers is 2, registration, you can see it captured 24 seconds ago. Let's see on the map. And here we are. It's in my country. That's very good. Okay. Okay, it's still on our site, Varesh Airlines. Yeah, that's basically how it works. You will probably, when you see for your first flights, you will probably get more excited more and more, which is this is a nice hobby, right? This is a nice hobby. And yes, that's basically it. About antenna, yes. About the antenna, I was using the VIP antenna from 7. That's called VIP because of this VIPs here. Now this was from 700 megahertz all the way to the 2700 megahertz VIP antenna. This type of antenna is typically marketed for GSM, LTE, and Wi-Fi applications, like 2.4 gigahertz Wi-Fi applications. As you know, like it is usable for this antenna as well. But it also covers the 1090 megahertz very well, which is good, which makes it suitable for ADSP reception. Now, as I said, as I always say, this is not ideal choice for lower frequency signals like AIS or APRS, which we will cover in the next lectures. They have their own antenna. Now, but for ADSP, this antenna will probably get your, not probably, this antenna will get your job done. As I always say, you can create your own antennas at home. This is a bit advanced, but you can do it. Just a bit of research. And if you want to maximize your range and reliability, a dedicated 1090 megahertz antenna is much better in this case. Like you can use the quarter wave ground plane antenna. This is a simple, low cost, and very effective. You can also collinear, also called co antenna. This has a higher gain, and it is also ideal for long range reception. And you can also use this cone antenna. This is a wide band, and it's good if you want to monitor many frequencies at once through less optimized than the first two I said here. And always remember, antenna placement is very crucial on in this case. Now, as much as the antenna itself, now put it at as high as possible, ideally a near window or on a rooftop, and use low coaxial cable like RJ6 or LMR 400 to minimize signal loss. In this case, we are just doing the amateur software-defined radio, since we don't need to use any additional coaxial cable other than let's actually quit. Firstly, disable the receiving and then remove the antenna always, just to make sure to not break your HackRF. This is a very fragile device. And yes, that's basically what antenna is, just a one top and all the way cable. And just before this lecture, I ran a test and successfully received ADSB data from passing aircraft as well. And yes, you have seen it as also. And to verify that your system is working, this flight websites like Flight Radar 24 or Flight Aware, you need to use this, or you can use this if they show aircraft overhead, like on your dot, at least like 30 kilometers or 50 kilometers. It depends on your signal strength and other things, but 30 kilometers is good. Now you need to look at this map, and if you can see the aircraft on your area, but on HackRF you cannot, now it's time to adjust your gain settings, antenna placement, or check your cabling if it's if you did it correctly. And to recap, we have learned the meaning and the history of ADSB, reviewed the HackRF gain stages, understood the data fields in ADSB messages, and looked at antenna choices. In the next part of this lecture, we will move on to the running the actual HackRF with the AIS boards on the APRS and other tools that you can use as a receiving state, right? There's a lot of things here. We will also check the TPMS on my car as well.